Alright, so we've handled each case separately. Let's put it together. So in this case, we see that A is equal to 3. So amplitude-wise, we're 3. So we're, again, the equilibrium is the x-axis, so we're going to be 3 up and 3 down. And then the B is equal to 1/2. And so 1/2 sits between 1 and 0. So we are expecting a horizontal stretch. Right? What's the new period? Well, it's 2 pi over b, which is 2 pi divided by 1/2, which is 2 pi times 2, which is 4 pi. All right, so we're going to basically break up the interval from 0 to 4 pi into 4 quadrants. But again, rather than doing that the hard way, I hope I'm convincing you this is the easy way, right? Take this sine graph. What are the basic points? Well, 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, -1, and 2 pi and 0. And these are impacting y, and this is impacting x. So all we have to do is manipulate the data. So all my y values, they're all being multiplied by 3. All my x values, well, they're being divided by 1/2. But this means we're actually multiplying them by 2, right? Because dividing by 1/2 means we actually multiply by 2, just like we did there. So what's our new data points? Well, x, everything's being multiplied by 2. So we get 0. If we multiply that by 2, we get pi. If we multiply that by 2, we get 2 pi. If we multiply that by 2, we get 3 pi. And if we multiply that by 2, you get 4 pi. So notice I quite naturally went from 0 to 2 pi to 0 to 4 pi. And we've broken things up in quarters. All right, y is being multiplied by 3. So 0 times 3 is 0. 1 times 3 is 3. 0 times 3 is 0. -1 times 3 is -3. And then we get a 0. So there's your big data points. So this graph, when we go graph it, my y scale, how about we go 1, 2, and 3, -1, -2, and -3. And my x graph, right, we're going to go in terms of pi. Pi, 2 pi, 3 pi, and 4 pi. And so where's all my manipulated data? Well, we have 0, 0. We have pi and 3. We have 2 pi and 0. We've got 3 pi and -3. And we got 4 pi and 0. So there's your sine function, right? Goes up, comes back down, reaches a low point, comes back up. That's a classic graph of sine. It's been elongated and it's been stretched both vertically and it's been stretched horizontally. Comparing it, right? So in red, this is 3 sine of 1/2 x. In normal, in blue, right? It's 0, 0. We're talking pi over 2 and 1. We're talking pi and 0. 3 pi over 2, and right, so there's your sine graph under normal circumstances, right? Over its original period, 0 to 2 pi, right? But you can see it's been both stretched horizontally, and it's been both stretched vertically by a factor of 3 vertically, and by dividing it by 2, which is by 2, right, in a horizontal set. So there's the comparison. You can see the stretching happening in both directions. All right, so what about cosine? Well, in the next graph, we have 5 cosine of 1. Oh, by the way, too, mentioned our amplitude is 1, but notice we're 3 above and we're 3 below, right? This equilibrium, which is the x-axis. So our amplitude is 3. Wanted to point that out. Sorry. So here, A is equal to 5. So there's our amplitude. B is equal to 1/4. So we're expecting a horizontal stretch. How far? Well, our new period is 2 pi over b, so this is 2 pi over 1/4, which is 2 pi times 4 over 1, which is 8 pi. So our new period is pretty big, right? It's actually 4 full revolutions, if you would. So just to get one full cycle. So again, rather than trying to figure that all out and break things up into fourths, just manipulate data, right? So what do we know about cosine? 0 gives us 1. Pi over 2 gives us 0. Pi gives us -1. 3 pi over 2 gives us 0, and 2 pi gives us 1. So there's our normal cosine graph. What's happening to it? Well, all the y values are being multiplied by 5. All the x values are being divided by 1/4, but that means they're actually being multiplied by 4. Okay, so what's our new data? Well, going along the x-axis, 4 times 0 is 0. Sorry, pi over 2 times 4 is 2 pi. Right? 4 times pi is 4 pi. Multiply that by 4, and we get 6 pi. And multiply that by 4, we get 8 pi. So quite naturally, you just see, right? We went from 0 to 2 pi to 0 to 8 pi very naturally just by manipulating data. The y-coordinates multiplied by 5. We get that. And so in terms of graphing one full cycle of this guy, right, it looks like, you know, we'll go 1, 2, 3, 4, 5. 1, 2, 3, 4, -5. And then I'm going to break this up into 2 pi and into 4 pi and into 6 pi and into 8 pi. Plotting my data, we got 0, 5. We got 2 pi, 0. We got 4 pi, -5. We got 6 pi, 0. And 8 pi, 5. So here's what this graph looks like, right, over this new period. Classic cosine graph stretched out. In comparison, right, we usually have from 0 to 2 pi, right, is where the action usually occurs. So there's half and half and half. So we usually start at 1 and 0 and -1 there and here. So here's your normal cosine graph, right, under normal circumstances. So there's cosine of x in blue, and here's cosine of, or 5 cosine of 1/4 x. So you definitely see it's been vertically stretched by a factor of 5, and it's been horizontally stretched by a factor of 4 basically, right, because we multiplied everything by 4. And so it's definitely been horizontally stretched and vertically. Amplitude-wise, again, the equilibrium is the x-axis. We're 5 above and 5 below. So the height of the wave in any direction is 5. So amplitude, like we said, is 5. So there you have it. All right. So we'll do another round here. I'll try to make it harder. All right. But hopefully you guys are just seeing again and again and again. If you can manipulate the data points and understand what to do with the A's and the B's, dare I say this is pretty easy, right? You get all your nice points to plot, so you can identify what I want, like all the intercepts and everything like that. I actually think if you get really good at this, you'll be faster than your calculator. All right, but that's something for you guys to decide. I know I'm much faster than a lot of calculators because I just, you know how to do this. So we'll see if you guys get to there. All right, but let me cut to the new video and we'll do some more examples.